Well, good evening, everyone, and welcome to Et al, the ultimate bar science show.
Yeah, science.
This feels nice. I have been on the stage at the Rio, but I'm especially glad.
Oh, I've been on the stage at the Rio too before.
Oh, shush. I've missed your sass. Jane
you?
Goodall,
Thank you.
everyone.
She's very
Give a round of
sassy.
applause for Jane Goodall over here.
Thank you. I have a new show on Netflix. I'm not sure you've heard.
What's it
Kind
called?
of a big deal. Jane. No idea.
I am Jane.
I'm Jane. And this is Carl Sagan. Maybe you've heard of him.
I am Carl Sagan. If I talk like Kermit, then maybe I can talk like Carl. We could probably kill the music, but I think maybe.
I don't know. That went
Actually,
really well with your
turn
intro.
The music back out. Turn the music back out. Let's have some
It was better
fun.
before.
Because this is a bar science show. It's not just your regular science show that you're going to find on Netflix that Jane Goodall hosts.
Okay. Regular? Let's not get mean here. This is a special bar show. That means there is beer, there is shenanigans, there is almost certainly a lot of sex to be had.
There might be a swear or
Maybe
two.
one or two.
Malarkey. There's
so
gonna be some
much malarkey. Malarkey right here.
Before we go anywhere, we do have to acknowledge that we are on the unceded territory of the Musqueam, the Squamish, the Tsleil-Waututh Nations. I do want to acknowledge, we should give a shout out to this room here, the Rio Theater, which has now been saved.
Woo! Woo!
That was part of the reason why we want to come here. Jane and I, see how long we can keep that up.
see how long you can keep it up.
Yeah.
I'm already giving up.
Jane and I, we usually host Nerd Night over at the Fox Cabaret. Hopefully nobody went there first. There was a few people that thought we were doing there tonight, but we're here at the Rio. We'll be back there next month. But we wanted to open this up because this is the third year in a row that we've done this big collaboration with all of the other bar science nights, which is what it all is. It'll be a big celebration of doing science in bars and getting drunk.
Well, yeah.
Or just me. Maybe I'm the only one that gets drunk.
You're the only one who gets real drunk. The whole idea is that science is not, science can be done sort of secluded, but it works best when it is collaborative and when we can share it together and talk about it and have fun with it and figure out why everybody cares about it so that people will continue to care about it and they will continue to fund it. So
well
that's
said, Jane.
I just want people to keep giving me money to study rats. That's all I want.
So, like I said, how many people have ever been to a Nerd Night before? Oh, okay.
Ooh.
Wonderful. They may not actually know who this person is because you've been away for the past year, but you're back.
Okay, 6 months.
6 months. It feels like a long time.
It feels like a long time, yeah.
But tonight is not just Nerd Night. We also have two other amazing groups that are going to be at Grace's stage. We'll do some intros later. We got Curiosity Collider. Has anyone ever been to a Curiosity Collider event?
Yeah!
Okay. And then after the admission, we're going to hear from Science Slam. Has anyone ever been to a Science Slam?
Ooh.
Not just here in Vancouver. Maybe they have them all across the world. They're pretty cool.
And if you haven't been before, you're about to get slammed.
So, and as you may see up there on the screen, we want to interact with you guys. So we're doing a bit of an experiment. We're using this program called Glisser, glsr.it. If you go to that little website, you can play a little fun poll. That was sort of like a little warm-up.
It'll ask you for an employee ID. Just put in a fun name.
Just put in a fun name.
We can't figure out how to change that. So, like, mine would be like Rat Girl. I could come up with something better, but I won't. So put in something fun that we can identify you by, because by playing that, you are entered to win prizes. Yeah. And if your name is Matt and there are 10 Matts, we cannot find you. And there will be 10 Matts here, almost certainly.
So we haven't had the trivia portion yet. The polls that are up that are sort of like to warm you up. Those are going to come back. We're going to ask some trivia questions, give away tons of amazing prizes that we have to give away tonight, which we do have to give a shout out. All of the logos that you see up there, some of them are other nights that happen here in Vancouver. We're going to talk a little bit more about them. Even a cousin of Nerd Night is happening over in North Van.
A cousin.
There you go. And a whole bunch. We're going to talk about them a little bit later. They've donated a whole bunch of prizes, so there's going to be a chance to win prizes. But we're also going to use the Glisser to ask questions at the end. So make sure that you guys are going on there. We're going to have some fun with these polls as we get going. And hopefully we won't get sloppy drunk, but we probably will get sloppy drunk.
This guy for sure is going to.
So how you guys feel? You guys ready to get going?
Yeah, we're ready.
All right. So to kick us off, our first act tonight, like I said, is going to be Curiosity Collider. And I love these folks. I first saw them just over at the Cafe du Soleil right over here. And what they do is they bring scientists and they bring them together with artists. And it's all about the collaboration of these two disciplines. You yourself perhaps like started off in one of these disciplines. Perhaps you did a little bit of marriage of both. And that's what they're all about. And they have been doing events for the last few years. I'll let them sort of like talk a bit about more. But what you're going to see right now is a video presentation from their last event that they did at the Museum of Anthropology, all about quantum futures. And you saw a little bit of that happening down here. They'll explain a lot more of that. And then after the video, we're going to hear from Char Hoyt, who's the artistic director of Curiosity Collider, and James, who's also from the Quantum Physics Institute, to talk all about quantum futures. You ready for that? All right, let's get going with Curiosity Collider.
Why did the chicken cross the road? It didn't. It's always on both sides.
So for example, if I throw a ball at you, okay, if I throw a ball at you, how a quantum physicist would calculate what actually happens is to whom?
To me, to the ball,
To the ball. To the ball. To the ball. So if I throw it at you, like, oh, the ball is flying like, in this trajectory.
Yeah.
How a quantum physicist would calculate, it would be like, oh, the ball is actually flying. So like, here's me, here's you, right? Saying, oh, the ball is flying like so. But the ball is also flying like so. And the ball is also flying
Why
like
is it also flying like so?
everything you can dream of happens
In the quantum world.
in the quantum world.
A photon takes 8 minutes and 20 seconds to travel from the sun to the earth. In this time, I invite you to take a journey with me through the fabric of space-time and open your mind to an abstraction of the quantum realm in everyday life.
We've been thinking about the perceptual shift you need to make to go between the physical world we're familiar with and the quantum world. So there's the world that you might have tried to describe in high school physics using collision formulas and graph paper. And there's a world where two particles separated by galaxies can somehow be in relation to each other. Both worlds are happening. The old formulas still describe something useful about matter and how it relates, but it's a partial description.
Hey everyone. I'm James Day. I'm a research associate at the Stuart Blusson Quantum Matter Institute at the University of British Columbia. I'm an experimentalist in condensed matter physics, and that means I spend most of my day working with my hands on materials and with equipment. Mostly I study electrons and their behavior in a variety of materials. Sometimes these materials are simple metals like copper or gold, but sometimes they're rather more complicated. And this is important because if you know how electrons behave, you actually know a lot about the thermal and electrical properties of a material. A lot of the experiments that I do happen in an environment of ultra-high vacuum and really low temperature, like nearing absolute zero, way colder than outer space. And some of what I do as well is communication and outreach, and this is what got me introduced to Char.
Hi, I'm Char, and I'm a multidisciplinary artist and the managing creative director for the Curiosity Collider. Last spring, we were given the opportunity to curate one of the Museum of Anthropology's night shift events, which are a monthly performance event, evening performance event, where that showcases artists and performers from the community. And the Collider had been wanting to do a show about quantum mechanics for a while, and the museum loved the idea of having artists imagine a quantum future. And so we put out a call for proposals, and as you saw from the video, we found a lot of fantastic work. The collaborative aspect of this show was in these activities that you guys were playing with earlier, and we'll have a chance to interact with as well. And we wanted our guests to have fun feeling creative while they were learning about quantum mechanics.
Yeah, so quantum mechanics is pretty wild. Quantum mechanics is really a description of the motion and interaction of atomic and subatomic particles. Importantly, it incorporates a number of non-intuitive concepts, including but not limited to the quantization of energy, wave-particle duality, the uncertainty principle. And I call them non-intuitive because these concepts simply don't apply to the macroscopic world in which we live. We didn't evolve to understand quantum mechanics, and developing a deep and broad understanding is not something that's easily done. Fortunately, we've got a primary tool that helps us to understand complex physical phenomena, and that is the analogy. So when you can map a new and interesting system onto a simpler system that you understand, if you find the right analogy, that you can really ride it quite a long way. Now, analogies eventually break down. It's important to understand where your analogies might fail, but if you find the right one, it can really carry you quite a ways. There's great value in being able to see from a new perspective or communicate through new language. And related to that, that's one of the wonderful things about developing a working relationship with an artist. They force you to do that.
And that creation of the languages and analogies is something that really resonates with artists and that we can sink our teeth into. And it's one of those the similarities between the processes of the arts and sciences. We both create languages and analogies. And with quantum mechanics, there's a lot for an artist to imagine visually, and it can be a very compelling challenge to turn these concepts into something tangible.
So to meet this challenge, one of the first things we had to do was come up with a list of ideas. We wanted a bunch of good ideas. The way you get some good ideas is to get an even bigger list of ideas, and you can generate a larger volume of ideas when you've got a bit of a team together. So I put out a call at the QMI to get some volunteers. We got 3 interested graduate students. Etienne is here with us tonight, but we also had Oz and Alex, and we sat down and we brainstormed thinking about all of the different analogies and models that we use to explain and understand a lot of the work that we do at the QMI. And then we very proudly took this long list of ideas to Teresa and Char at the Curiosity Collider for some curation. There were a lot of back and forth meetings. We met online and in person, and they curated pretty quick. They took an axe to some of our dearest ideas and chopped it down. They whittled it down to a nice small list of ideas that they thought could work in an activity form and were confident would work with a bunch of non-experts.
Yeah. We needed to have a lot of patience and foster an open exchange of ideas. I mean, we didn't squash everything, but neither side could be shy about any miscommunication or getting something wrong. We had to just be very open and very objective, a process that grew organically. Not a subjective one, like in the arts. We had to let go of the ego and find a common understanding and language, really, to talk to each other. As an artist, I couldn't go in expecting what we created to be an extension of my art practice. Not all art and science collaborations go that way, but for this one, it was less about my creativity and more about communicating the concepts and sparking creativity in the participants.
Yeah, and a lot of the back and forths we had with the artists were not unlike how an experimentalist might speak with a theorist. So just by virtue of our different trainings, we think about things a little differently. We've got different language that we might use, and conversations can get quite cyclical. And that cycling is there just so that each ensures the other is understood properly. Sometimes you have to revisit an idea with some new words. Sometimes you have to attack a concept at a new angle. You do what you have to do to bridge that initial gap in misunderstanding that I think necessarily exists, given that we all have grown up in our own cultures and language, working and living. So we had a bunch of these back and forth meetings, and we're able to put together some activities and instructions that we thought would work pretty well. And then we had to get into some field testing. So these activities, I gave them to my 7 and my 10-year-old kid. We gave them to some other graduate students who hadn't yet been involved in the project, and we just sort of let them go. We saw where they got stuck, where they got confused, where they went off on tangents, and we used those observations and feedback from these people to refine the activities and come up with some revised instructions that we thought at least had all the information that was required for them to run successfully, and also in a minimal number of steps. We didn't want it to be a reading exercise or anything like that.
Next slide. So while Teresa and James were sharing the concepts with their peers, I was in the studio dipping over 200 styrofoam balls in paint and gluing hundreds of plastic shot glasses together. in very specific shapes, right? We have to have a certain number and whatever. Yes, it's all about the angles. And yeah, so there was a lot of trial and error and a lot of show and tell meetings with James, Etienne, Oz, and Alex. After we got all the concepts down and I had some of the materials built, we had a meetup together with the artists from the show, and basically we tested out our activities on the artists. Which we basically learned that we needed to refine our ideas even more, and that clarity is so important, clarity of instructions. And you guys may know that or already be confused by our instructions tonight, but yeah, so we wanted people to go away with a nugget of understanding and not more confusion, and that was a challenge.
Yeah, I would say there are really two takeaways that I wanted our participants to have. One was this little nugget of understanding or nugget of knowledge, something that if they were sufficiently interested, they could go home and do a deeper dive into whatever it was that they had learned that evening. So if a visitor left thinking like, holy cow, I didn't even know that Feynman diagrams existed before, or I can hardly believe that frustrated materials are a thing that a physicist might study. And we study things called frustrated materials at times. It's frustrating. The other takeaway, though, aside from giving them sort of a Wikipedia rabbit hole to go down, we wanted them to take away an appreciation of how real working quantum physicists actually use analogies and models just like these almost every day. I like to joke sometimes that half of all of the complex phenomena that happens in the world can largely be understood if you just think of a mass on a spring. And it's for a lot of things, it's true. So I wanted the second takeaway to be this recognition that analogies are powerful and that we really do use them in our practice.
Yeah. So the first activity was the Feynman diagrams, where we invited guests to draw their own, and we displayed them like we're doing here. We provided the component parts of the diagram and on an info sheet with the lines, arrows, squigglies, and circles, and gave simple instructions and felt pens and let them loose. As you can see, some people strictly adhered to the instructions and the rules, and others were very creative. And we actually had some three-dimensional stuff as well, and there were some dinosaurs, and it was very cool. The second activity, oh yeah, there's more of the creative ones, which were great. The second activity was the lattice building exercise, a guided discovery of the structure of quantum materials presented in the form of a puzzle type game. The participants were provided instructions and a scientist's guide. The plastic cups represent the underlying lattice structure, essentially a canvas upon which the quantum materials are built. And the styrofoam balls represent the atoms, and the arrows represent the spins of electrons. From there, participants could build graphene or antiferromagnetic structures or some other exotic quantum materials. Our hope was that the participants left understanding that starting from a very few different building blocks that you can construct a wide variety of quantum materials.
Yeah, so for the show, we just had a couple of tables like we do here. They were bigger at the Quantum Future show. And at these tables, we stationed a handful of graduate students who are great for running this sort of activity. First of all, they've got a lot of the requisite background knowledge to answer questions and have conversations about people who are curious about these sort of things. But because they often also serve at TAs at the university, teaching courses, they're well trained in like Socratic questioning, and they're really good at not just giving an answer away, but nudging people along. So, I mean, I'm confident that most people who came to the activity tables at the Quantum Futures had a genuine learning experience.
Yeah, they did a fantastic job of creating an open and non-intimidating environment, and it was fun and frenetic and atmosphere with everyone buzzing around and tables making stuff, drinking, chatting, and learning about quantum mechanics. It was a great contrast to the performance part of the show, which was a calmer, more contemplative, meditative reflection on how the quantum realm can be interpreted and expressed in our daily lives. Overall, the collaboration was a huge success, I think, and will have a life beyond the event. James and Teresa are actually currently writing 2 papers on each of the activities, and Teresa used them as teaching tools at her UBC physics summer camps for kids. So a big thank you to all the artists and scientists in the show, and to the wonderful people at the Museum of Anthropology for hosting us and our quantum collision of art and science. So now we would like, end slide. And now we would like to give you a taste of the performance part of the show, and spoken word Angelica Paversky is here to share a couple of the poems that she did at the show. Thank you so much for having us here tonight, and here's Angelica.
Hello, everybody. I'm Angelica, and just as Char said, I was part of the show. Actually, if it's possible, lighting God person, if you are in the room, could I see some more faces? I just kind of actually want to make some eye contact so I can make some people uncomfortable as I talk. I'm a media studies student at UBC as well, and I'm a poet. So oftentimes I like to use analogies and metaphors to really try to understand quantum mechanics myself. But before I get into that, I'm going to do a poem, and then I'll explain some more. So this poem is called Strands. Someone was the first person to come up with the word invention, but the word itself was an invention. How was it described? A strand. You can't really confirm your own birth. Pictures and videos could be lies. Isn't it suspicious? You don't know how you were born and you don't know how you will die. Another strand. What if the words that we spoke were not the words other people processed? What if we're just in this possessed tunnel of perception? A third strand. What moments define us as people? What makes something too much or too little? Strands theorizing in my mind. Strands asking me who, how, why? Analyzing all these strands under an infinite microscope, I see that we're all just made out of strands. So Sogato, hydrogen, 1 electron helium, 2 electron. This is how you spell boobs on a calculator. I know how to make a lemon battery. A squared plus b squared equals a squared plus b squared equals Sogato. I've learned there's no point in questioning because I'm such a left brain, right brain, girl, boy, Pisces, Scorpio. I can't think that way because my horoscope told me so. The capital of Comoros is Moroni. Strand 1, strand 2, strand 3. Too many strands, too many strands, too many strands. I need a genius to think for me. We're losing sight of this infinite ball of twine that makes up our life. I think that everybody is stifled. We hold rifles to our brains and tell ourselves we aren't good enough, God enough, strong enough, strand enough to ask questions. Stand tall, but not with strands strapped to your chest that will leave you with constant regret you can't identify. Instead of looking at that 5-inch grid, thrive off the magnifying glass on your fingertips. We are not 1 or a million, the water or the sky. We are wolves with oranges falling out of our eyes. We are thudding elves with thumping elbows, empathy to every single passerby. We are tornadoes of volts, blinking pupils, good people with questions. We are wrong to be silent. We are wrong to be reliant on thinking the way that we were told we should. We could just open our eyes and see that we are merely memorizing. We are terrorizing our brains with formless capitals, Jeopardy gibberish. Instead of listening to the voices in the distance that say a billionth of anything is all that we know. And so we could grow together. Strand 1. I wonder when we stop growing and start dying. Is it a moment that can be defined? Strand 2. I wonder what the world looks like on the other side of the telescope. Strand 3. I wonder if we will ever tie our strands to become an infinite safety rope, or will we be stranded? Thank you. Thank you, lighting God, for turning it. Oh, no. It was good. You were, thank you. Yeah, I liked it. Okay, so anyways, back to my quantum mechanics stuff that I was saying, which, not that poem wasn't, but the pre-monologue I was giving. So sometimes I like to go on dates with people, and I don't know if you all see the parallels between dating and quantum mechanics, but to me it's very clear. So I find that like once I have a really good read on guys and I implicate myself in that situation, it completely changes, you know? Yeah, okay. Some people are like, I get it. Other people are like, oh, what? That's quantum mechanics too. It's like dating. You don't really understand it, even if you're a scientist. Yeah, and then, oh yeah, this is a haiku that I came up with. I like Shakespeare sometimes. I did English 12, so. This is called Hamlet. Hamlet looks in the mirror and quietly says to be and not to be. All right, so I'm going to do another poem now. This poem is called Let's Celebrate. Let's celebrate being everything at once. Instead of candlelit dinners or picnic lunch breaks, become a big middle finger coming out of the steak. Instead of dancing for him or seeing his smile widen, strip for Zeus and pole dance for Poseidon. Instead of rhyme or romance, just become renounced, an unpoppable pimple, a dimple that looks into the face of anyone who has ever betrayed you and made you question yourself. Instead of being here or there, be everywhere like an electron. Listen to your angels and your demons. Listen to the crack of death in your cardboard chest, but also the spirit in your semen. Like an electron, be here and there, border bliss and blitzkrieg, asking yourself mercilessly, whose failure would bring you the most grief, and yodel with glee when your answer is only Jesus with robot teeth, because sometimes love, loss, and grief hurt so bad we have to split ourselves between different absurd realities, and maybe that's just how it's meant to be. Maybe two electrons forcing you to look the wrong way, or two hemispheres in our brain, are not rivals but unions. A holy communion of the cerebral but inseparable scribbles on our psyche, and this might be the closest representation to God you will ever see. The very thing that makes you up, your electrons and your thoughts, are meant to be indefinite. And dot our exclamation points and straighten our lines with curves, and burst through the code that we were programmed with, in bliss and in sadness at once. Thank you. So more on quantum mechanics in daily life. Sometimes, like, you know, when you're having a moment of peace, and yeah, people are like, no, what's that? Like, I didn't hear it. I also love like emceeing events. This is a total tangent, but I'm always like, sometimes like, oh, who's having a good time? And like, you just hear nothing. I'm like, who's feeling worried? And people are like, woo! So who's feeling worried tonight? Yeah, it's all good. Anxiety is part of quantum mechanics. But yeah, sometimes I would look at my phone and like I'd be just meditating or whatever, and I would look at my phone, and it's in that moment that like Char Wi-Fi decides to call me and tell me that I didn't pay my bill. And that's quantum mechanics, because when you look away, they call you again. You know, like, okay, no. So this poem is also for you. Yeah. I look at an electron. It sits in stillness. I look at an electron. It pulls in position. I look at it again. It moves in momentum. But the electrons are always doing the right stuff anyways. Every time I look at myself, I feel like I should be doing something else, moving out of the mundane, causing myself to change. I never look at electrons anymore, because when I do, they move away from their place, and they were doing all the right stuff anyways. So I breathe out. I take a look at quantum indeterminacy, moving into the feeling that sometimes it's necessary to rest in the incomplete. I look to electrons, never at, and I find it is rather the feeling of not knowing what you will get and seeing that that is always where you need it to be. Necessary incompleteness breathes like a god that rules us, and we don't need the name for. I make a necklace with the notion of necessary incompleteness. I dance in it. I dream in lit daylight. I flip my wit. I stand in it. I deck myself out in chrome. I use trombones and rulers of the cosmos to paint my unpretty path. I revel in bells of becoming alive. I split my own regulations in half. I make radioactive half-lives in all my divine thoughts. I keep nuggets and pieces of feelings, but I let the geometric go like a series of reality, take out the grief from understanding anything fully. I submit to necessary incompleteness, to take over the infinite subdivisions in any infinity. Juggle the music of my name, unfazed by the spread of a world that cannot be described by my episteme. Not knowing how I will die, but eating some cake anyways. Not knowing how my career will shape, but making art to feel alive. Not knowing a part of the equation is just part of the equation sometimes. Some days I may be paralyzed on the canvas of trying to figure it all out. But like Vincent van Gogh and Went, and we're all just starry, starry crumble lust in the sky. Sparkling away in the dust into the midnight, I'm burning in the bliss of being alive. I'm running late to my funeral. I'm running unprepared, but drunk and grim and burning in the sight. That sometimes there is beauty in the undefined. And every time you try to look too hard, it slips away from you. So I will rage deep into the unwavering bliss of the blank night. Thank you. Should I go? No?
Are you still going?
I have one more thing I'm going to do, if that's okay.
Yeah, no worries.
Oh, okay. Thank you. You can stay with me. Okay. Yeah, if you want to. Yeah, you can be part of it.
No.
Well, I'm
gonna be your straight man.
Okay, cool. Well, I'll do one haiku and then one 1 minute poem, and then I'll leave.
Yeah, absolutely.
And do you want to do sound effects for
Sure.
my 1 minute
Absolutely.
poem? Okay, cool. Let's do that. Okay, so this is another haiku. It's called Stillness. I went to China this summer. I traveled light like a photon. Yeah, there we go. Nice. Okay, so this poem, this last one, I'll drop the mic. By that I mean I'll pick up the mic. Rap terms are confusing. Okay, so this poem is called Burn Down Your Beliefs. And I'll need, you know what, why doesn't everybody just follow what Michael does for sound effects while I do this poem?
Jesus. Why did I walk on stage?
Who wants to walk on stage? We can have another groupie. Yeah, come back. Well, can you interpretive dance while I do this? I think the audience wants you to interpretive dance. Yes, okay. What was your name again? I'm Rupert. Let's give it up for Rupert.
So what am I doing? I'm doing sound effects?
You're going to do sound effects,
okay.
And you're going to do the movements. Okay?
Specifically, I do science-based comedy.
Okay, this is science-based comedy in dance form. All right. So yeah, it's called Burn Down Your Beliefs. So audience, when Michael makes a sound, I want to hear you make the sound. And when Rupert makes the dance move, I want you to also, just try.
I want you all to make the dance move.
Yeah. That's a little aggressive. That's okay. Okay.
90%, that's a data point.
Data. Okay, so this is the poem. It's called Burn Down Your Beliefs. Okay, is everybody ready? Does everybody know what they're doing? Okay, cool. It's all on me now. Okay. Castrate your TV. Burn down your beliefs. Make music from your morbid memories. Take your firework failures and fizzle them into sonic flume. Because this here and this now is a proton parading out of a bang for you.
Oh, fuck yeah.
It's how hydrogen fused. How water moved. How the earth grew from a mushroom. How the star sonic boomed your name like a silhouette they will travel to the future for.
Carl Sagan.
How a cow turned its beak and moved for you. How this is what it feels like to be alive before the grim sinks in.
Oh, yeah, this feels nice.
The night that I burned down my beliefs, I danced with myself like the space between my atoms was the kindest lover.
Ding, 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 ding.
That night, I listened to my radio like it was my airwave holy.
Now for the weather.
That night, I wish you had heard how this music moves for you.
And now we have...
So stretch your nuclei. So stretch your nuclei because it feels so good to shift in the space in your skeleton and keep on moving. Because soon you'll be in sheets with your genesis, catching fire with your breathlessness. You are on the precipice, and the space between your mouth, your music, and your mind is the whole Bible of endlessness I will recite for you. This world was built to evolve with you, so let it move you like magic. Thank you.
Angelica, everyone.